Hello, my name is Benjamin Doran, and I will be your guide through the short instructional video answering the questions, what is modulo and why, as computer scientists, should we use it in our programs? So what is modulo anyway? Modulo is an operation much like multiplication or division. It returns the answer of what is the remainder of a division operation. So if we have 5 modulo 3, the answer is going to be 2 because 3 goes into 5 once, and there's 2 left over. In most computer languages, we're going to use the percent symbol to indicate modulo. So we've seen that 5 modulo 3 equals 2, and we can continue that logic for 4 modulo 3, which would return 1, and for 3 modulo 3, which would return 0. But what about 2 modulo 3? Well, 2 is not divisible evenly by 3, so it goes into 2 0 times, and then we have 2 left over, and then we can continue that for 1 modulo 3 and 0 modulo 3, which gets us 1 and 0. So after writing these answers down, we can start to see a pattern forming. There are 2 important features to this pattern. The first is that it's ordered. It's always going to be 0, 1, 2, so on. And the second is that it's never going to return an answer greater than the number we're modulating by, in this case 3. So in this instance, our pattern is going to be 0, 1, 2, 0, 1, 2, and that is going to be true for every whole number that we modulate by 3. To help understand why this somewhat arcane example can be helpful in real life, it helps to think about how we use modular arithmetic every day. We use it on our clocks. So we don't necessarily care how long it's been since the Big Bang, but we do generally care how far we are into each day. What modular arithmetic allows us to do is to take a very long or linear progression, like time, and break it into smaller segments, like days, hours, minutes, seconds. So for days, we count up to 24, and then we call it the next day and start counting again. For hours, we start counting the minutes up to 60, and then start counting over again. The most important limitation to modulo to consider is that modulo cannot tell us how many cycles we've gone through. It can tell us what stage we are within a cycle, but after it repeats, that prior information is lost. So, knowing the position of the second hand gives us no information to where the minute hand is. It tells us how far we are into a minute, but not how many minutes we have. While the various intricacies to modular arithmetic can be fascinating, it may not be immediately obvious how this relates to computer science. When writing code, we often have to try to fit an unknown set of input into a very finite and known set of outputs. For instance, Jill is trying to implement a new online ordering system for a restaurant. She has 3 chefs, and she doesn't want any of them to be overworked. Looking at some pseudocode, we can see that she has written out that while the restaurant is open, if a new order comes in, assign that order to order number modulo 3. She has 3 chefs, and she has assigned each one a number, 0, 1, and 2. And she has decided that all new orders that come in will also be assigned a number 1 greater than the previous. So she can have order 0, 1, and 2, and so on. Jill knows that by using modulo, for each new order that comes in, it will be assigned to the next chef in the sequence. The system certainly seems fair, with each new order being assigned to the next chef, but it does have some limitations. For instance, this algorithm has no sense of the scale of difficulty. One order might be for a souffle, while the other one might be for pancakes. This algorithm also assumes that each chef is equally skilled in all dishes. So it might assign the souffle to the chef that's really good at pancakes, and assign the pancakes to the chef that's really good at souffle. Going forward, we may want to determine order numbers to be based upon the food item contained. We could assign souffles to be a multiple of 3, and pancakes to be a multiple of 3 plus 1. That way, we can assign each food item to an individual chef. The important thing to recognize about modulo is that it whittles the large down into the small. It can help categorize large sets, and it can help us perform repetitive sequential tasks, such as assigning chef 0, then chef 1, then chef 2. Modulo does have its limitation in that it has no memory of how many times it's repeated itself, but that's where you, the coder, comes in. As you continue to learn computer science and write more code, I hope you think about how Modulo can help you whittle down large problems and categorize inputs. Thank you for watching this short instructional video.